In his book Doomslinger, Kurt Cave explained the nature of reality, showing the parallels of real-world science and the philosophies of various religious beliefs that describe how the physics of our universe work. That book was a very simplified version, made easier to understand for the average person. This is the source paper of the hard science that supports Cave's theory of reality. The Cosmic Horizon and the Brain, a holographic interface for consciousness. Introduction. The universe, as we experience it, may be a vast illusion. One of the most groundbreaking ideas in theoretical physics, pioneered by Leonard Susskind, is the holographic principle, which proposes that the three-dimensional universe is a projection of information stored on a two-dimensional surface, known as the cosmic horizon. According to this principle, what we perceive as a 3D world might actually be a lower-dimensional manifestation of a higher-dimensional framework, possibly extending into 7 dimensions. Furthermore, the flow of quantum bits, qubits, the fundamental units of quantum information, may traverse these dimensions, providing a new understanding of how reality itself is structured. This paper proposes a novel hypothesis. The cosmic horizon is not located at the distant boundaries of the universe, but on the surface of the human brain. The brain functions as a holographic interface, where higher-dimensional information is projected into our conscious experience of reality. We will explore how quantum information theory and the holographic principle relate to this hypothesis, particularly through the behavior of qubits in multidimensional spaces. The holographic principle and quantum information. The holographic principle posits that all the information contained within a three-dimensional space can be encoded on a two-dimensional surface. Initially formulated in the context of black holes, this idea was expanded by Susskind to encompass the universe as a whole. In black hole physics, the event horizon, the boundary beyond which nothing can escape, is thought to store the entire information content of the black hole. The entropy or information of the black hole is proportional to the area of the event horizon rather than the volume inside, a relationship mathematically described by S equals A divided by 4 times the Planck length squared, where S represents the entropy, information content, A is the area of the 2D surface, and LP is the Planck length, the smallest measurable unit of space. Expanding this idea to cosmology, Susskind theorized that the universe we perceive may be a 3D projection of information encoded on the cosmic horizon, the distant boundary of the observable universe. According to this view, the universe's true information content resides on this 2D surface, and what we experience in 3D space is the result of holographic projection. Quantum information and qubits in the holographic principle. At the core of this theory lies quantum information, specifically the behavior of qubits. In classical computing, a bit can be either 0 or 1, but a qubit in quantum mechanics can exist in a superposition of both 0 and 1 simultaneously. The superposition collapses into a definite state only when observed. The holographic principle suggests that quantum information in 3D space is not stored locally, but encoded on a 2D surface or a higher dimensional framework. In this context, qubits serve as the fundamental units of quantum information that could exist across dimensions, allowing information in 3D to be encoded and manipulated via qubits in higher dimensional spaces. The concept of ADS/CFT correspondence in theoretical physics provides a concrete realization of this idea. According to this correspondence, a theory of quantum gravity in a d+1 dimensional anti-de Sitter space, ADS, can be described by a conformal field theory, CFT, residing on the d-dimensional boundary. This means that higher-dimensional quantum processes in the ADS space can be projected as lower-dimensional phenomena on the boundary. The ADS/CFT correspondence has been worked out for different dimensional setups, including cases where ADS space is 5-dimensional, suggesting the possibility of a 7D space serving as the higher dimensional, bulk, space, with our 3D world or 4D spacetime as its projection. This leads to the idea that quantum information, encoded as qubits in the higher dimensional bulk, can transfer between these dimensions. The transfer of qubits between dimensions is a profound implication of the non-locality inherent in quantum mechanics. This non-local nature means that information in one-dimensional framework could affect or be transmitted to another, providing a mathematical and physical basis for quantum information transfer between 3D space and a higher dimensional structure. The role of qubits and superposition. One of the most profound aspects of quantum mechanics is superposition, where a qubit can exist in multiple states until it is observed. In the context of the holographic principle, all qubits in 3D space may exist in superposition within a higher dimensional framework until they are observed. This means that, from the perspective of quantum information theory, the states of these qubits are undetermined and multidimensional until they are collapsed through measurement. Once observation occurs, the superposition collapses, and the qubit takes on a definitive state within 3D space. This aligns with the idea that quantum information from a higher dimensional framework is projected into the 3D world we perceive. The math that supports this is rooted in the principles of quantum mechanics, where the wave function describing the system collapses upon measurement. Moreover, the geometry of spacetime itself may be influenced by the entanglement of these qubits. Recent developments in holographic quantum entanglement suggest that the geometry of spacetime could emerge from the entanglement patterns of qubits across dimensions. In the ADS/CFT framework, the number of entangled qubits on the boundary is directly tied to the structure of the higher dimensional bulk, providing a geometric link between quantum entanglement and spacetime. The brain as a holographic surface. Let us now apply these ideas to the human brain. The cerebral cortex, the outer layer of the brain, is packed with billions of neurons and synaptic connections, responsible for processing vast amounts of information. This dense network may function as a holographic surface, similar to how information is encoded on the event horizon of a black hole or the cosmic horizon. In this model, the brain's surface encodes higher-dimensional quantum information, which is projected into 3D space as conscious experience. Just as the cosmic horizon encodes the information content of the universe, the brain may encode quantum information from higher dimensions, acting as a quantum interface between our 3D reality and a higher dimensional framework. This hypothesis resonates with the holographic brain theory proposed by Carl Pre-Bram, which suggests that memory and information are stored as interference patterns across the brain, similar to how a hologram stores information across a 2D surface. According to this theory, the brain does not store information in localized regions, but rather in a distributed, holographic manner. The hypothesis: the cosmic horizon as the surface of the brain. The central hypothesis of this paper is that the cosmic horizon described by the holographic principle is not located at the distant edges of the universe, but on the surface of the brain. In this model, the brain surface serves as the holographic interface where higher-dimensional quantum information is projected into 3D space, creating our conscious experience. Perception and consciousness as projections. If the brain functions as the cosmic horizon, then perception is not merely the result of neural activity, but a projection of higher-dimensional quantum information through the brain's holographic surface. In this framework, what we perceive as reality is the result of quantum information from a 7D space being processed and projected into 3D experience. Moreover, consciousness arises from the interaction between our brain's holographic surface and the quantum information stored in higher dimensions. There is a two-way flow of quantum information between these dimensions, allowing the brain to receive, process, and potentially influence higher dimensional states through the projection of qubits. Transfer of quantum information, qubits, between dimensions. One of the most intriguing implications of this hypothesis is the transfer of quantum information between the third dimension and higher dimensional frameworks, such as a 7D space. This idea is supported by the ADS/CFT correspondence, which shows that actions or states in a higher dimensional bulk are directly related to actions or information in the lower dimensional boundary system. In the case of the brain, qubits encoded in a higher dimensional framework could be transferred to the brain's holographic surface, creating the foundation for perception and consciousness. This transfer of qubits might also explain non-locality in brain function, where information is distributed across the brain, much like how quantum information is non-locally stored on the cosmic horizon. Implications of qubit transfer between dimensions. Quantum gravity. If information can transfer between dimensions via qubits, it might bridge the gap between quantum mechanics and general relativity, offering insights into a unified theory of quantum gravity. This could revolutionize our understanding of both the universe and the brain. Emergence of spacetime. The transfer of quantum information between dimensions supports the idea that spacetime might not be fundamental but rather an emergent phenomenon from deeper quantum processes. The entanglement of qubits across dimensions could give rise to the geometry of spacetime, meaning that the very fabric of the universe is a byproduct of quantum information flow. In this model, the 3D world we experience emerges from the projection of quantum states encoded in higher dimensional spaces, possibly through the surface of the brain acting as a holographic interface. Applications in quantum computing. While still theoretical, the idea of transferring quantum information across dimensions opens speculative pathways for quantum computing. If qubits can traverse multiple dimensions, quantum computers might be able to harness this capability to perform computations in higher dimensional spaces, offering far more powerful computational frameworks than those constrained to 3D space. This also hints at new technologies that could exploit the brain's ability to process quantum information, leading to potential advancements in neural interfaces or quantum-enhanced cognitive systems. Consciousness and reality. The hypothesis that the brain acts as a holographic surface connecting 3D reality with higher dimensions challenges our conventional understanding of consciousness. Conscious experience, from this perspective, may not just be the product of neural activity, but the result of higher dimensional quantum information being projected into 3D space. This opens the door to exploring consciousness as a quantum phenomenon, potentially linked to the non-locality seen in quantum entanglement. Conclusion. This paper has explored the possibility that the cosmic horizon described in the holographic principle is, in fact, located on the surface of the human brain, rather than at the edge of the universe. By extending the framework of quantum information theory, specifically the behavior of qubits and their superposition states, we propose that the brain functions as a holographic interface, connecting the 3D world we perceive with the higher dimensional quantum reality. The implications of this hypothesis are vast, potentially redefining our understanding of space-time, quantum mechanics, and consciousness. If the brain indeed processes quantum information from higher dimensions, it could explain how perception, cognition, and reality itself are intimately tied to the fundamental nature of the universe. While speculative, this hypothesis opens new doors for scientific exploration into the relationship between quantum mechanics, the brain, and the nature of reality itself. Works cited. 1. Susskind, Leonard. The Black Hole War. My Battle with Stephen Hawking to Make the World Safe for Quantum Mechanics. Little, Brown and Company, 2008. 2. Bekenstein, Jacob D. Black Holes and the Second Law. Lettere al Nuovo Cimento, Vol. 4, 1972, Pagine 737 a 740. 3. Pre-Bram, Carl H. Brain and Perception, Holonomy and Structure in Figural Processing. Lawrence Earlbaum Associates, 1991. 4. Penrose, Roger, and Stuart Hameroff. Consciousness in the Universe, a Review of the Orchestra or Theory. Physics of Life Reviews, Volume 11, Number 1. 2014, pages 39 to 78. 5. Meldiceno 1. The Large N Limit of Superconformal Field Theories and Supergravity. Advances in Theoretical and Mathematical Physics, Volume 2, 1998, pages 231 to 252. 6. Ryu, Shinsei, and Tadashi Takeyanagi. Holographic Derivation of Entanglement Entropy from the Anti-de Sitter Space / Conformal Field Theory Correspondence. Physical Review Letters, Volume 96, 2006.